but there was, I forgot the cable. And this lecture is recorded not because I'm a narcissist, even though that might be part of the reason, but also for your convenience, and because, well, I like to learn from my mistakes. Can you please help me? Can you see my face in the camera, or do you have to tilt it up? You have to screw the handle there. Thank you.
That's okay.
Thanks. So I'll upload this lecture on my YouTube site, YouTube channel, and that's where the slides will be. And the slides will also be in my slides page, and I'll write down the web address during the break. Any questions so far? I can tell you a few things about myself. My name is Karim, and I'm a PhD student here. I'm in my final year, and my research topic has been bioethics and ethics of technology. And but the intersection between social science and engineering and science has been also a topic of great interest for me. Come in. I'm really happy to give this lecture. Okay, so the main question that I'm going to address in this lecture, and that I will hope to answer, is the following one: how can science be used to devise policy? This is a picture of a very famous architectural building that, in a sense, combined science and policy in a very science, engineering, and policy in a very interesting way. The building's name is Panopticon, and it's a model designed for a prison. And the man behind it was a famous philosopher called Jeremy Bentham. This design has been criticized, of course, but it has also been very influential in a lot of areas of policy debate. Check it out on Wikipedia. So this is the general outline of this lecture. I'm going to talk about some problems for a science-based policy. I'm going to talk about the evidence-based medicine and how that has progressed and what we can learn from it. I'm also going to talk about the role of big data. I'm not going to go too deep into that, but I'm going to mention it at least. And finally, I'm going to connect this to engineering. More specifically, what your role could be in thinking about connecting science and policy. And one of them is to think about the constraints of humanity or human civilization. This is typically something that social scientists and political pundits are very bad at thinking about. And also about this concept of engineering safety that I'm sure that many of you have absorbed implicitly during your education. But I want to state the principles of engineering safety a bit more explicitly and show how they can be applied to social science and to the general thinking about risks in society. Any questions about this? All right, so we'll start with the first point here. Yeah, I'm going to turn off the lights here. So I think this is a very beautiful picture. It's a visualization of this mathematical concept, and it shows us that complexity can emerge, vast complexity can emerge from very simple rules, and this is also what we see in society. So basically what we're seeing here is that we're zooming in on the edge of this figure, and you can see how how large the surface area is. The problem with society is that there are no general laws of the same kind as we have in physics. We cannot, there is, to my knowledge, no general law about the development of society that has this general aspect that Newton's laws have. You cannot use the same principle to infer the behavior of the individual person and the behavior of societies. So in comparison, ballistics are simple. You can, with a few simple equations, predict the trajectory of an object, but you can't do this. There are no comparable laws in social science. It's also the case that in social science there has been this ideal, I mean the natural sciences have been an ideal for social scientists for a long time. So they've tried to emulate the tools and the thinking and the way of presenting facts from science. And I think in one way, of course, this is a great thing, trying to be rigorous, trying to be clear, trying to be empirical. But the problem is that the scientific tools from the natural sciences are often too simple to be applied without qualifications in social settings. This graph is the so-called Phillips curve, which shows the correlation between inflation and unemployment. But as you all know, if you've read economics in high school, this curve showed to be not to describe reality accurately after the oil shocks in the late 70s, and doesn't seem to be showing doesn't seem to be a good guide for today's world either, where we have record low inflation and sky-high unemployment in the most of the Western world. And the reason for this is that the subject matter of social science is far more complex than even the most complex natural sciences. And then some of you might be climatologists or climate physicists, and you start thinking like, hey, my subject is really complex too. Try calculating whether it's going to rain in Rio de Janeiro in 2015. It's not like a walk in the park. Well, this is true. So I'm not saying that science is really easy and that there's no complexity in science. But the thing with social science or societies is that they crucially depend on natural phenomena, and on top of these phenomena there is an additional layer of complexity. So to be able to know whether or not people in Rio de Janeiro will be hanging out in the outdoor bars or in the indoor bars in 2015, we need to know whether or not it's going to rain in Rio de Janeiro. So we would need first a weather prediction, and then we could apply our models and try to figure out whether or not they're going to be partying outside or inside. And as you can see, it's like an added layer of complexity. It's also the case that in climate physics or in climate science, the general laws are fairly well understood. So we know pretty much how air reacts to how much vapor air can contain at a certain temperature, and so on and so forth. So the general principles are fairly well known. It's the multitude of interaction effects amplified by chaos theory that creates the complexity. In social sciences, we have the complexity, but we don't have the understanding of the general laws. We don't know how many people, we don't know that much at all how, for instance, a crowd behaves in different conditions, for instance. This is also a common scientific tool that is used in natural sciences and that has been applied too much and without sufficient consideration and qualifications to social sciences. The classic normal distribution curve. Society is not normal in this sense. And most famously, this was completely wrong when the movement of house prices was plotted on this curve, where economists predicted that the chance of a nationwide fall in property prices for in more than 30% was basically impossible. They said they predicted that this would happen once every 100,000 years or so. So it's not something we need to worry about in the short term. But of course that happened. So then you have to ask yourselves, was this extremely unlucky, or did the models not portray reality accurately? Well, I think the latter is correct, of course. Another problem with social science or scientific a scientific approach to social science is that we tend to conflate the idea of risk with the idea of uncertainty. So these are two important concepts that need to be explained a bit more. Risk is what you have in a casino. Risk is what you have in a casino, and it's when you know the payoffs and you know the probability of each outcome. So if you're playing a roulette, say, you know that there are 36 slots in a roulette, right? Okay, let's assume that there are 36 slots. I should have read about this before, but you know that there's roughly 1 in 36 chance that you will win if you place a bet on, say, 2. And you know the payoffs if you win, and you know the costs if you lose. So this is a situation of risk, so to speak. This situation is very rare in real life. Why is it so rare? Because we rarely know the probabilities of each outcome, and we rarely know exactly the payoffs of each outcome. In real life, we have to do with uncertainty. And that is when we don't know at all the probability of each outcome. So we can't say, for instance, if you say that you loan money to your friend. Your friend really needs money, you give him 10,000 krona. You really don't know how probable it is that your friend will pay you back the money, right? But it's also the case that you don't know what could happen if you pay him the money, or if you give him the money, or if you don't. So if you don't, your friend might perhaps get kicked out of his house and start a chain of events that will be very bad for him. Or perhaps it's a very good thing that you didn't loan him this money, because then he stopped with his gambling, say. And this is how real life looks like. It's not a casino. Real life is much more like a jungle. When you go into a jungle, you really don't know what's going to happen. You might find some really nice fruit, or you might get bitten by a snake, or, whatever can happen. And by thinking that society or that social outcomes under this risk paradigm, we tend to underestimate. First, we tend to neglect outcomes that we haven't imagined beforehand. So if we couldn't imagine that a 9.1 earthquake could occur, we just neglect that risk, that possibility. And also it gives us a false sense of security when it comes to our predictive abilities. And of course, this complexity and this uncertainty is ignored at a high cost. And this is a black swan, as you can see, very nice bird, I think. The black swan is also the title of a book that makes this point, I believe, in a very compelling way. It's of course not the only book that argues this point, but I think it's a nice book. I recommend it to everyone of you to read. That events or outcomes that we have failed to imagine are the most dangerous to us, because we're completely vulnerable to them. And I can give you two examples. The first is the attack on Pearl Harbor. That was the starting point for the American involvement in the Second World War. The attack of Pearl Harbor was one of the greatest military disasters in American history. And why was it so devastating? Because the Americans were completely unaware of the possibility that the Japanese would attack them directly. And to us it seems quite silly. I mean, how could they think this? But this is the way we work. We tend to neglect possibilities that seem obvious to us in retrospect. In fact, the Americans were very worried about sabotage, Japanese sabotage. So that's why they concentrated their the ships in Pearl Harbor were packed very tightly so that it would be easier to have surveillance around them. But of course, to pack a lot of air carriers and battleships very tightly also implied that it was very easy to destroy them with a limited number of airstrikes. And the second example is, of course, September 11. The American agencies for national security did simply not imagine the possibility of someone hijacking an airplane. The fact was that a few years before, there was a suggestion to make an exercise involving this kind of attack. So this was a kind of a draft. Let's see if we can make a strategic exercise, strategic war game, where this kind of attack is, where a terrorist hijacks a plane and uses it as a weapon. But the scenario was rejected as being too fanciful. So there was simply this idea that the improbable, the strange, the things that seem strange to us also seem improbable to us, is very dangerous. And it's partly dangerous because we fail to anticipate risks. But it's also dangerous because it causes us to feel very safe. And a lot of this safety culture, or risk management culture, as it's also called, is about the idea that if a situation or setting is inherently safe, then we can maximize output from this system by centralizing the operations, by removing diversity, but also by eliminating redundancy. And this is what you can say was done in Pearl Harbor when you packed the ships very tightly together, and they didn't deploy warships around Hawaii because they thought that the Japanese were regrouping. They thought that the Japanese probably were going to attack Russia, and so on and so forth. So they felt like this is an unnecessary expense. Of course, in retrospect, it wasn't. And the perhaps most famous example of the catastrophic consequences of risk management is, of course, the Titanic. So the Titanic was a huge ship, the most modern of all times. It was unsinkable. Everyone knew that Titanic was unsinkable. Why? Because it had a reinforced hull, it had compartmentalized sections in the hull, so it would have needed, and it had like automated systems to pump out water. So it was believed that it would need many simultaneous hull breaches to sink. So, okay, Titanic was unsinkable. And then some economists said like, okay, but if Titanic is unsinkable, why do we have lifeboats? Lifeboats are really expensive. They take up a lot of space. We can use this space for recreation or to make the living areas larger and more comfortable, and we can charge more. This is a completely unnecessary expense, was the argument. The engineers kind of say like, well, yeah, you know, but it might be a good idea anyway, you know. And the economists are like, okay, you're completely irrational. You told me that this ship is unsinkable. Then we don't need lifeboats, and we don't need life vests. But in the end, it was thought that it would be a bad PR not to include some lifeboats. So in the end, some lifeboats were included, but roughly half as many as was needed for the passengers on the ship. Yes, and of course we know today that the Titanic was not unsinkable, and we also know that the lack of lifeboats was a very bad idea. Right? That many more lives could have been saved if there had been more lifeboats. So what we could say about evidence-based policy or science-based policy is that what we first need to do is get rid of this idea that we can objectively and safely arrive to sure knowledge. This idea that these graphs convey of precision and objectivity and law-likeness in social science is dangerous. There's also another aspect in this illusion of objectivity, and it's that it claims to not these kind of claims when you say that this intervention has this marginal cost and this marginal benefit, and we should do it or we shouldn't, is that you are masking moral assumptions, normative assumptions, ideological assumptions about the different items that could be valuable. And you hide this behind models that seem very objective. And this is also problematic because it makes it very difficult for citizens and for people to question these models. Say like, hey, your lines here, what about equality? Right? How are the costs and benefits distributed? And I think this picture shows this pretty well. Who is benefiting from building a mine with a poorly secured dam close to a village? And who is being harmed? Is it the same people? Well, not in this case. So even if the cost-benefit analysis would recommend building this dam or not reinforcing the dam sufficiently, we might still object to it on moral grounds, based on the case that this project benefited different people than were subjected to the risk. And perhaps you remember this case was a few years ago where a village was inundated by this toxic sludge released from a deposit, like a huge, basically a huge lake of toxic sludge from a mine. I'm not sure what kind of mine it was. Does anyone remember what mining was. Might have been copper, I'm not sure. Anyway, as you can see, this is not fun at all. A lot of pets died, and well, the whole village was basically ruined. And we can also talk about how risks and benefits are distributed not only in space, but also in time, of course. What we are doing with the climate, putting out a lot of carbon dioxide, might be favorable seen from a cost-benefit perspective, but is it fair? Is it fair that future generations should shoulder the burden that we have imposed on them without benefiting? Another aspect that creates this complexity is that technology is extremely important for social change. Without taking account of the technological development of societies, we can't really know what's going to happen. Cars are a very typical example. They completely changed the urban landscape of American cities and some European cities too. Before cars were introduced, it was thought that the greatest environmental hazard of of cities in the next years would be manure, because they had a lot of horses everywhere, and the horses, well, they were shitting around, and this was a huge problem at the time. And social scientists at the time extrapolated. They said, like, okay, the amount of manure on our streets have been increasing like this, and then they made like, okay, so we're here, so if we extrapolate from this, oh my god, 1950s will be like, we'll have like a meter of manure on average. And of course, they failed to take into account this technology. And this is the thing, technology cannot easily be predicted. I don't think any of us know what energy sources are going to be dominant in 20 years. We might have our hopes, but we don't know. And we don't know whether or not cars are going to be replaced with something else in 30 or 40 years. So this is also an aspect that makes prediction very difficult, you see here. Okay, so I've been very pessimistic at the moment, and said mostly what we can't do. And I think this is important because I think the first step on approaching policy issues from a scientific point of view is to accept the challenge and accept our lack of knowledge about what works in society. So that's number one. Number two, and that's what I'm going to talk after the break, I'm going to talk about what we can do. But before we leave for a while, I would like to see if you have any questions or thoughts. What do you think? Yeah.
About what? About this?
Well, about what I've been saying, yeah. About the complexity, do you have any examples or thoughts or counter examples? Okay. All right. So I'll let you go for 15 minutes. I'll see you later.